Imagine reporting like the absolute best financial quarter in the history of your entire company.
Right.
Your revenue doesn't just grow. It nearly triples year over year. Your gross margins essentially double.
Yeah.
You hike your dividend by 30% because your free cash flow is practically a fire hose at this point.
Yeah, you're just printing cash.
Exactly. You step back, you drop the mic, and the stock market immediately punishes you with a 14% drop.
It's just a phenomenal corporate paradox. You execute flawlessly, you shatter industry records, you have customers basically lining up around the block, and Wall Street still hits the sell button.
Welcome to today's deep dive. We are looking at a really fascinating stack of materials today, all centered around Micron Technology's latest financial disclosures.
Yeah, it's a deep stack.
It really is. We've got their Q2 2026 earnings call transcript, the official financial press release, their earnings presentation deck, and a highly critical CNBC News article analyzing the market's rather upside-down reaction to all these numbers.
Our overarching mission today is to decode that disconnect. We're going to look past the flashy financial headlines and dig into the actual physical realities of semiconductor manufacturing.
Right, because it's not just software.
Exactly. We need to understand why memory, which is a component historically viewed as just a cheap, cyclical commodity, has quietly become the absolute most critical bottleneck in the entire global AI revolution.
So if you are listening to us online right now, whether you follow the tech sector closely, whether you're actively tracking the AI arms race, or you're just curious about why financial markets often seem completely divorced from reality, this deep dive is going to give you the ultimate insider perspective.
Definitely.
But before we get to the numbers, just a quick note, Emma's Ju Yuping. Okay, let's look at the raw data, because it really sets the foundation for this entire mystery.
Yeah, the financials here are just structural anomalies for a hardware company. Like in fiscal Q2 of 2026, Micron reported total revenue of $23.86 billion.
Wow.
Yeah, that is up 196% year over year. But the truly staggering figure is the sequential increase. From Q1 to Q2, revenue jumped by over $10 billion.
Wait, just to contextualize that for you listening, a $10 billion jump in 3 months means Micron essentially generated the equivalent of an entirely new Fortune 500 company out of thin air just in a single quarter.
I mean, that's exactly what it is. And they did it with unprecedented profitability. Their gross margins hit 75%.
That's huge.
It is. And even more aggressive is their guidance for Q3.
Okay.
They're predicting revenue of $33.5 billion with an 81% gross margin.
Let's pause on that 81% gross margin for a second.
Oh.
In the hardware manufacturing space, where you have to physically dig silicon out of the ground, refine it, and build it into complex machinery, 81% is bordering on software margin.
Yeah, it's almost unheard of.
It's like a bakery suddenly being able to sell a standard loaf of bread for 5 times the normal price, simply because there's a global flour panic,
Yep.
It implies that the product is no longer just a component, it's a gatekeeper.
Right.
For decades, memory, like DRAM and NAND, was basically treated like steel or lumber. When the market flooded, prices crashed. When supply dipped, prices rose.
And the earnings call actually addresses that historical view directly. The management team explicitly stated that the artificial intelligence boom has, and this is a quote, fundamentally recast memory as a defining strategic asset.
So it's not a raw material anymore.
No, not at all. It is the structural foundation of the AI era.
So what changed under the hood? I mean, why is the AI industry suddenly so utterly dependent on massive amounts of memory? We know processors from companies like NVIDIA are doing the actual computing. So where does the memory bottleneck actually come from?
Well, it comes down to the architectural shift from early generative AI to what we call agentic AI.
Okay, agentic AI. Break that down.
So early AI models operated on a basic prompt and response mechanism. You ask a question, it predicts the next word, and gives you an answer. Agentic AI is fundamentally different. These systems are designed to perform complex, multi-step tasks independently.
Oh, I see.
Yeah, you give the AI a high-level goal, and it initiates workloads. It reasons through obstacles, writes code, tests that code, and then adjusts its strategy based on the results.
So to do that, the AI needs to maintain a continuous thread of logic, right? It has to basically remember the initial goal, all the parameters you set, and every single step it has taken over, say, the last hour.
Exactly. That is called the context window. And holding that massive context window open requires a staggering amount of highly volatile, incredibly fast-working memory.
Right, the short-term memory.
Yes. If the AI accelerator is the brain's processing center, the DRAM is the short-term memory keeping all those variables active. The earnings call noted that the data center DRAM requirement in advanced AI accelerators has actually doubled from last year to this year alone.
Doubled in 1 year. That's insane.
Without that memory, a multi-billion-dollar AI model simply cannot function.
Which perfectly explains the panic from the buyers.
Yeah.
If memory is now this strategic gatekeeper and supply is tight, customers just have to secure it at all costs.
They really do.
The materials show Micron is completely restructuring how they sell to capitalize on this exact panic. They are migrating their key clients away from traditional LTA's long-term agreements and forcing them into SCAs, which are strategic customer agreements.
Yeah, and historically, a long-term agreement in the semiconductor world was a bit of a misnomer anyway. It usually only covered a 12-month period.
Right.
But on this call, Micron announced they just signed their first ever 5-year SCA.
Okay, wait, let me push back on the logic there from the
Yeah.
buyer's perspective. Tech moves incredibly fast. A single year is a lifetime in the AI cycle.
Oh, totally.
So why would a massive, highly sophisticated tech company agree to lock themselves into a 5-year contract to buy memory at what appears to be peak 81% margin prices? You're committing billions of dollars without knowing what the tech landscape even looks like in 2029.
Because the alternative is existential failure.
Really, just complete failure.
Yes. The financial risk of overpaying for memory in year 4 is completely dwarfed by the catastrophic risk of not having any memory in year 1. There is a specific data point from the earnings call that illuminates this.
What's that?
Micron stated they currently only have the physical capacity to fulfill 50% to 2/3 of the requirements for their key customers over the medium term.
Whoa. So if a major cloud provider asks for 1 million units, Micron's response is, best we can do is 500,000, maybe 660,000.
Exactly. Now put yourself in the shoes of a hyperscaler building a billion-dollar AI data center. You have the land, you have the power, the cooling, the processors. But if you can only source half the memory you need, that facility cannot operate.
So you're left with a billion-dollar brick.
Right. And your competitors pull ahead in the AI race. The SCAs provide price and volume commitments over a multi-year horizon. The customers aren't just buying silicon, they are buying a guarantee that they will survive the next 5 years of the AI arms race.
Wow. That dynamic changes the entire power structure of the tech industry. But it also raises a pretty glaring question,
What's that?
If you are Micron, and these massive companies are handing you billions of dollars in guaranteed 5-year contracts, and your margins are sitting at 81%, you have a mountain of guaranteed cash. Why aren't you just taking that cash and building 100 new manufacturing lines tomorrow? Just crank up the supply to meet the demand.
Well, the financial markets often assume software rules apply everywhere, right? That you can just spin up a new server and instantly double your output.
Yeah, but hardware doesn't work like that.
Exactly. The semiconductor industry is bound by the brutal realities of chemistry, physics, and construction. The earnings call uses some pretty dense terminology to explain why they can't just flip a switch.
Yeah, I saw terms like cleanroom constraints, declining bits per wafer from node migrations, and the HBM trade ratio.
Right. So let's decode those physical constraints. Start with the HBM trade ratio because high bandwidth memory, or HBM, is basically the golden child of the AI hardware world right now.
All anyone talks about.
Yeah, and it's a marvel of engineering. Instead of laying memory chips flat next to the processor, you stack multiple DRAM dies on top of each other vertically and then connect them with these microscopic wires called through-silicon vias.
Okay.
Micron is currently sampling HBM4, which involves 36 gigabyte 12 high stacks and even 48 gigabyte 16 high stacks. But this vertical stacking creates a massive manufacturing bottleneck.
I think it helps to translate this for the listener. Think of standard memory production, like building a sprawling, single-story suburban neighborhood. You can pack a lot of houses onto a flat piece of land.
That's a great way to look at it.
Moving to HBM is like deciding to build a 16-story skyscraper on that exact same plot of land.
And that analogy holds up perfectly when you look at the physics. To build that skyscraper, you need a massive, complex foundation. In this case, a foundational logic-based die that manages the data traffic for the entire stack.
Right, because all those floors need to talk to each other.
Exactly. You also have to physically drill through the silicon to create the elevator shafts, those through silicon vias to connect the layers. Furthermore, stacking active silicon generates tremendous heat, so you have to engineer complex thermal dissipation pathways, which requires even more physical footprint.
Meaning on the exact same physical silicon wafer, you are actually producing significantly fewer functional gigabytes of memory because so much of the space is taken up by the structural engineering required to make it a high bandwidth stack.
That is the HBM trade ratio. For every wafer you dedicate to HBM, you are actively cannibalizing your output of standard memory. As AI demand forces Micron to produce more HBM, their overall volume of bits produced actually goes down.
That's wild. And that gets compounded by the second constraint they mentioned, right? The declining bits per wafer from
Yeah.
node migrations.
Yes.
Micron is migrating to their cutting-edge 1-gamma DRAM and G9 NAND nodes. You would naturally assume that as technology gets more advanced, efficiency goes up.
Eventually, yes. But during the transition phase, you are pushing the absolute limits of physical science. These new nodes require extreme ultraviolet lithography to print patterns that are practically at the atomic scale.
Which is mind-bogglingly small.
It is. And when you shrink the architecture that small, the manufacturing process requires significantly more steps. More steps mean more time in the machine and a higher probability of microscopic defects ruining a portion of the wafer. Your initial yield of usable memory drops compared to older, mature technologies.
So the physics of advanced memory means you are actively producing fewer chips per wafer. To fix that, you just need more wafers.
Which means you need more factories.
Right. And that brings us to the $25 billion CapEx bill.
Yeah. For fiscal 2026, Micron announced their capital expenditures will exceed $25 billion. And looking into fiscal 2027, their construction spend alone will increase by over $10 million year over year. They are building or expanding fabs in Idaho, New York, Japan, and Singapore.
And the scale of that construction is just hard to overstate. They aren't just pouring a concrete slab and moving some desks in. They're building greenfield cleanroom expansions.
A semiconductor cleanroom is arguably the most complex, pristine manufacturing environment on planet Earth.
It's basically a spaceship on Earth.
Pretty much. We are talking about facilities where a single speck of dust can destroy millions of dollars of inventory. You have to build massive subfab levels just to house the chemical delivery systems, the extreme HVAC filtration, and the vibration dampening foundation.
Right.
You cannot rush the construction of a facility that manipulates matter at the nanometer scale. It takes years to build the shell and months just to calibrate the tools once they are installed.
Which perfectly sets up the paradox we opened the show with. We have a company pulling in record-shattering revenues with 81% margins. We have desperate customers locking in half-decade contracts to guarantee their own survival. And we have an industry physically incapable of oversupplying the market anytime soon because of the complex physics of HBM and the years-long construction timelines for clean rooms.
It's a perfect storm.
It is.
Yeah.
So we turn to the CNBC article. Why on earth did the stock plunge 14% after they announced all of this?
Well, the article highlights a fundamental disconnect between financial market psychology and engineering reality. Context really matters here. Going into this earnings report, Micron's stock was already up over 300% over the trailing year.
Okay, so expectations were sky high.
Exactly. Wall Street expectations were priced well beyond perfection. Investors were actively looking for a reason to take profits, and they latched onto two specific data points to justify the sell-off.
The first being this concept of peak gross margins, right?
Yes. When investors saw the guidance for 81% margins in Q3, they panicked. They looked at NVIDIA, which is the undisputed king of AI hardware, and NVIDIA generally operates around a 75% gross margin.
Oh, I see.
So the market psychology dictated that if Micron is at 81%, it basically defies gravity. The assumption is that this must be the absolute peak, and therefore the only direction left to go is down.
Here's where it gets really interesting, though. It is deeply ironic. Wall Street demands infinite perpetual growth from tech companies. Yet the moment a company achieves a margin so high it secures massive capital, the market punishes them for it.
It's totally counterintuitive.
And the second reason for the sell-off was the CapEx bill itself, wasn't it?
Yeah, the $25 billion required to build those new fabs really spooked investors who are hyper-focused on near-term free cash flow. They see cash leaving the balance sheet today, and they penalize the stock.
The disconnect is just staggering. The market is punishing Micron for the exact physical construction spending required to build the factories that will enable the growth the market is demanding in the first place.
It's a classic short-term versus long-term clash.
Exactly. You cannot have record AI revenues in 2028 if you refuse to pour concrete in New York and Idaho in 2026.
The market reacted to the next quarter's cash flow statement while Micron is over here signing 5-year SCAs to secure the architectural foundation of the next half-decade.
Let's step away from the short-term stock market jitters for a minute and look at the actual real-world demand shaping that half-decade. We know cloud data centers are consuming memory at unprecedented rates. But what does this mean for the devices that regular consumers interact with every day?
The consumer market presents a really fascinating nuance in these sources. The earnings call noted that actual unit sales for PCs and smartphones might see a low double-digit decline in calendar 2026.
Wait, seriously, people are buying fewer physical phones and laptops.
Yes, driven by a mix of macroeconomic pressures and the fact that constrained component supplies are actually driving up retail prices.
Makes sense.
However, while global unit sales are down, the memory content per device is exploding, and this is entirely driven by the push for on-device AI.
So moving the AI processing out of the cloud and directly onto the phone or laptop in your hand,
Exactly.
which makes sense for privacy and latency. I mean, you don't want your phone pinging a server in Virginia every time you ask it to summarize a quick text message.
Right. But to run those localized models, the hardware requirements are skyrocketing. The call pointed out that AI PCs now carry recommended memory configurations of at least 32 gigabytes.
Just double the current standard.
Exactly. And heavy-duty personal AI workstations, like the NVIDIA DGX Spark, require 128 gigabytes just to run large language models locally. We are seeing the exact same trend in smartphones.
Oh, really?
In phones. Yeah. Flagship models are now shipping with 12 gigabytes or more of DRAM. That configuration represents nearly 80% of all flagships today, compared to less than 20% just a year ago.
Think about the smartphone you might be holding right now. It is rapidly transitioning from just a communication device into a localized AI server.
It really is.
But as massive as the PC and smartphone markets are, the earnings deck introduced a wild card for future demand that makes phones look like pocket calculators.
Oh, yeah. Robotics. Specifically humanoid robots.
Yes. Micron management explicitly stated they believe we are on the cusp of a 20-year growth vector in robotics, predicting it will become one of the largest product categories in the entire technology sector. But, I mean, why does a robot need so much memory?
Well, to operate a humanoid robot independently in a dynamic human environment, the onboard compute platform has to rival the systems used in advanced Level 4 autonomous vehicles.
Okay, let's unpack the mechanics of that. A humanoid robot carrying a package up your driveway isn't just following a pre-programmed path like on a factory floor.
No, not at all.
It has to render its environment in 3 dimensions in real time. It has to process multimodal sensor fusion cameras, LiDAR, tactile feedback. It has to recognize a dog running across the lawn, calculate wind resistance on the box it's holding, constantly adjust its center of gravity to remain balanced on 2 legs, and predict the dog's movement all simultaneously without relying on a cloud connection.
And that level of autonomous spatial reasoning requires a staggering localized context window. The earnings call estimates that a single humanoid robot will require over 300 gigabytes of memory and storage capacity.
300 gigabytes. A single robot wandering a warehouse or delivering groceries represents the memory footprint of 24 current-generation smartphones.
It's a massive leap in demand.
So when you factor in a 20-year horizon where robotics become ubiquitous in logistics, manufacturing, and eventually consumer homes, the $25 billion Micron is spending on new factories suddenly doesn't look like a risky overreaction. It looks like table stakes.
It does. It provides the ultimate context for the market reaction we talked about. A 14% dip is a mere blip when you recognize the fundamental transformation occurring. AI has stopped being purely a software trend. It is now a massive physical infrastructure build-out, and memory is the concrete.
Let's do a rapid-fire recap to synthesize the mechanics we've unpacked today so it really sticks.
Sure. First, the evolution to agentic AI has fundamentally shifted memory from a cheap, cyclical commodity into a defining strategic asset. It is the critical bottleneck for maintaining complex AI context windows.
Second, because of that bottleneck, Micron is capitalizing on customer desperation. They're transitioning from short-term agreements to locked-in 5-year strategic customer agreements, ensuring long-term revenue visibility while driving gross margins to an unprecedented 81%.
Third, they cannot simply flip a switch to meet demand. Severe physical constraints from the complex structural engineering of the HBM trade ratio to the reduced yield of advanced 1-gamma nodes, Micron must spend over $25 billion to physically construct new greenfield cleanroom environments.
And fourth, the short-term financial markets panicked at the upfront cost of that physical construction. They caused a stock dip that completely ignored the massive long-term demand curve being driven by on-device edge AI and the impending wave of L4 compute humanoid robotics.
I think the core takeaway here is that the limitless potential of the digital revolution remains entirely tethered to the physical realities of semiconductor manufacturing.
Which brings us to our final thought. We always like to leave you with something to consider that builds on the data we've explored today.
Yeah, based on the absolute desperation we are seeing in these SCAs, knowing that hyperscalers can currently only source 50% to two-thirds of the memory they need to survive the AI race, it forces a really provocative question.
What's that?
If memory is truly the ultimate strategic bottleneck, and building new supply takes years of complex construction, will we eventually see the software giants deciding that 5-year contracts just aren't enough security? As the AI wars escalate, will we see trillion-dollar AI software companies attempting to vertically integrate by physically acquiring hardware manufacturers outright, just to guarantee their own survival in the decades to come?
Wow. When the control of silicon physically dictates the future of artificial intelligence, traditional market boundaries might just disappear entirely. Thank you for joining us on this deep dive into the architecture of the AI era. Sup, Broche?